Good day, students. Welcome to my class on chemical combination. So we'll be looking at meaning of chemical bonding, valence electron octet rule, and we'll be looking at types of chemical bonding. So under that, we'll be checking electrovalent bonding, covalent, coordinate covalent, and metallic bonding. And lastly, we'll be looking at intermolecular bonding, and under that we'll be looking at van der Waals force, dipole-dipole force, and hydrogen bond. So at the end of this lesson, you should be able to explain what chemical combination is and why do chemical compounds bond together, or how do atoms form to come about or to result into chemical bonding. Alright, so let's start with what is chemical combination. What is chemical combination? Even from the name, you should know that is where there is interaction of chemical elements to form a what? To form a compound, where a chemical compound or element combine together to form a compound. It can also be called chemical reaction, combination reaction, or synthesis reaction. Okay, let's take an example. A plus B. Let's assume A is an element and B also is an element. So both of them chemically combining together will give us AB. So an element chemically reacting with another element will give us AB. Do you get that? Alright, so let's look at an example. Let's take solid sodium metal, which is Na, reacting with a chlorine gas to produce sodium chloride. Of course, you know that sodium is an element and chlorine also is an element. So both of them reacting together will give us sodium chloride. One element reacting with another element to give us a compound. So there are some terminologies we do use in chemical combination. So I'll be explaining those terminologies to you. The first one is compound. You know, in your SS1 you have been taught what compound is. Compound are chemical substances made up of two or more elements that are chemically bound together in a fixed ratio. Okay, for example, let's take sodium and chlorine. So sodium is an element, chlorine also is an element. Both of them coming together will give us a compound. Let's look at ions. Ions are a group of atoms that bears one or more positive or negative electrical charges. You know, you might have been seeing an element bearing charge as the superscript. Here they are called ions, and we have the positively charged ions called the cations, and we have the negatively charged ions called the anions. Okay, for instance, sodium chloride again. Sodium is a positively charged ion, which is Na plus, and chlorine is a negatively charged ion, which is anion, which is Cl minus. Okay, let's look at orbit or shell. Orbit or shell are in form of a circle. Those are the places, or that is a place, better still, where electrons revolve around. So it's a region that surrounds the atomic nucleus, containing a specific number of electrons. They are called orbits or shells. Okay, let's look at valency. Valency is the combining power of an element. So let's look at valency together with valence electron. It's an electron found in the outermost part of the shell, which take part in the chemical bond. For instance, you were taught how to use electronic configuration. Let's take sodium for an example. We have sodium electronic configuration to be 281. So the outermost part of the shell will be the one to take part in the chemical bonding, which is what? Which is 1. And let's look at chlorine too. The electronic configuration is 287. So the 7, which is the outermost part of the shell, will be the one to take part in the what? In the chemical bonding. So valency is just the combining power of an element. So let's explain how chemical combinations are formed. No, there is an attraction between atoms that enables the formation of molecules crystals, and other structures. The bond may result from the force between oppositely charged ions or through the sharing of electrons. So, how chemical bonds? They are bound together by chemical bonds. They are bound together by what? Chemical bonds. You will have seen HCl. You will see a line between H and Cl. That is a bond. So that is chemical bond. Are you getting that? So let's go to valence electrons, which is under it we'll talk about octet rule. Okay. The electrons in an incompletely filled outer shell of an atom are called valence electrons. Normally, the complete filled outer shell must have 8 electrons. Must have how many electrons? 8 electrons. So anyone with 8 electrons has completed the octet or has attained octet state. Are you with me? So the octet rule means or state that an electron or a shell, which is an outer shell, must have a complete filled outer shell, which is 8 number of electrons. Okay, noble gases, the electronic configuration of noble gases are always ending with 8. So that means the valence electron, which is the outermost part of the shell, have a complete octet state. They are stable. So that means noble gases are already in their octet states. An atom continues to lose, gain, or share electrons in order to have 8 electrons in the outermost shell, just like I explained. Now, if you go through the notes, you will see all the explanation there. Let's go to types of chemical combination. For your level, we'll be talking about 3 major types. The first one is electrovalent combination. Electrovalent bonds are produced when electrons are transferred from atoms of one another to atoms of another element, producing positive and negative ions. So the bond, which is electrovalent bond, is formed by the transfer of electrons between the atoms. For instance, we have 2 atoms. Let's take sodium and chlorine as an instance. So electrovalent bonding will be formed when there is transfer of electron between the atoms. So, and it can also be called ionic bond. Let's look at diagram under this note. We will see sodium, which the electronic configuration is 281. The outermost shell is 1, and I said we'll be using the outermost part of the shell for chemical bonding. And for chlorine, we have 287. We'll be using the 7 outermost. So 1 has 7 to complete the shell, and 7 has 1 to complete the shell. So sodium will transfer that 1 electron to chlorine, making chlorine to attain its octet state, and sodium too to attain its octet state. Are we together? So how do ionic compounds form? Ionic compound is a compound that is formed by ionic bonding. Ionic bonding occurs through a process called electron transfer, where one atom gives electrons to another. Ionic compounds are formed by bonding between oppositely charged particles, which is the cation and the anion. So ionic compounds form where there is transfer of electrons. So electron can either gain or lose. So when there is transfer, when there is electron transfer, that is when ionic compounds form. Are we together? Let's look at characteristics of electrovalent compounds. No, they are the strongest of all the bonds. They are very strong. They have a charge separation. They are mostly reactive. They have high melting point and boiling points. The molten state or the aqueous solution, they are very good conductors of electricity. now we'll be looking at the covalent combination. No, this one involves sharing of pair of electrons by each reacting atoms. So they share atoms together. No, it mostly happens on diatomic compounds, diatomic molecules, O2, Cl2. So they will share electrons between each other. Let's look at HCl. HCl has one atomos shell and chlorine has 7. So one hydrogen has 1 electron to complete the shell, and chlorine also has 1 electron to complete the shell. Both of them will react together to form a covalent bonding. You get that? So they react together. If you look at that diagram very well, hydrogen reacts with chlorine to give us a stable octet. Don't forget, the focus is for them to obtain octet state. They are stable states. So let's look at the properties of a covalent combination. They consist of molecules. They have low melting point and boiling point. They are insoluble in water and other polar solvents. They are non-electrolytes and they are non-conductors of heat and electricity. So let's go to the coordinate covalent bond. Coordinate covalent bond is also known as dative. So if I ask you that dative bond is the same thing as coordinate covalent bond. It's a very special type of covalent bond because there is only one atom participating. Other atom will just stay on its own, but there is one atom participating that is supplying both electrons that are shared. And an example is hydroxonium ion and ammonium ion. So this diagram here, we see oxygen. We see a pair of electrons coming to the hydrogen to make it complete octet. Alright, let's go to the last part, which is metallic bonding. Metallic bonding. No, we are all familiar with metal. We all used to see metal in our day-to-day life activities, of course. So a metal is regarded as a collection of atoms in which the valence electron move freely and continues through numerous uniformly spaced and positively charged nuclei. No, this is because atoms of metals have very few valence electrons, hence many vacant valence orbitals. Now let's check group 1 elements. Let's look at sodium. Sodium has 1 atomos shell. It's a very small valence electron. So it's very possible for them to form metallic bonding. So the electrostatic force of attraction between the positive nucleus and the sea of mobile electron is called metallic bond. So we can see the diagram here, how that we saw the positive nucleus moving randomly. There are electrons in between one positive nucleus to the other. So we saw electron shell moving freely, that is mobility, moving freely in between them. So let's look at the general properties, physical properties of metals. Number 1, they are very good conductors of electricity. Why do you think you put metal in a live wire and you will be shocked? Because it possesses high electrical and thermal conductivities. They are ductile, they are malleable, and they can be beaten into any form. They are ductile, they have high melting point, they have high tensile strength, they exhibit bright metallic strength, they exhibit metallic luster. Metals are lustrous, they are ductile, they are malleable. So those are the properties, the physical properties of metals. Okay, let's look at the last part, which is intermolecular bonding. No, it's just an English word. Inter. No, inter means what? It means between. Okay, it means between. So we see bonding between molecules. So we will look at van der Waals force, dipole force, and hydrogen bond. Number one, let's start with van der Waals force. This is a very weak intermolecular force because it appears and disappears. It appears, disappears, and it reappears again. So it's also known as induced dipole. So these are where atoms having the same electronegativity combine together. So they have the same electronegativity. Let's take H2, Cl2, O2. They always have the same electronegativity. Are we together? So it's a very temporal type of bond. Why? Because they appear and it also reappear. It disappear, reappear, it disappear. Let's go to dipole bonding. The bond electrons are permanently towards the electronegative atom. Let's look at HCl for instance. Between H and Cl, which one is more electronegative? Chlorine is more electronegative. So the dipole force will go towards the electronegative atom. So the less electronegative atom will carry a partial positive charge, and the chlorine will carry the partial negative charge. So they always have different electronegative atoms. So let's go to hydrogen bonding. This is permanent dipole where hydrogen is bonded to highly electronegative atom. So under hydrogen bonding, the hydrogen is bonded to highly electronegative atom. So they are mainly F, N, and O: fluorine, nitrogen, and oxygen. So anywhere you see hydrogen bonding to fluorine, nitrogen, or oxygen, that is an hydrogen bonding. Example is water, HF. So it's hydrogen bonding that helps us to know about boiling point of water. Are we getting? So as hydrogen bond increases, boiling point also increases. So the increasing order of intermolecular forces will be hydrogen bonding is greater than dipole, and dipole is greater than van der Waals force. What is the importance of intermolecular force? Why do we study intermolecular force? It simply helps us to determine the physical properties of molecules. So the knowing or the knowledge of intermolecular force helps us to determine the physical properties of molecules, like the boiling point, the melting point, the density, the enthalpies, fusion, vaporization, etc. So this is the concept of chemical combination. See you in the next class. God bless you.